A recently discovered asteroid named 2023 DW is set to pass by Earth on February 14, 2046, at a distance of about 1.1 million miles. The 160-foot wide space rock has been closely monitored by NASA's Jet Propulsion Laboratory's Sentry system, which tracks potential collisions with celestial objects. According to the European Space Agency's projections, the asteroid has a 1 in 625 chance of striking Earth in 2046. However, NASA's Sentry system predicts a chance of 1 in 560, making it the top-ranked object on NASA's impact risk list, with a ranking of 1 out of 10 on the Torino Impact Hazard Scale. Despite these concerning statistics, NASA officials have reassured the public that the asteroid has a very small chance of impacting Earth. However, the odds of impact could be significantly altered as more observations are completed, as noted by NASA's Asteroid Watch Twitter account. According to the Center for Near-Earth Object Studies, newly discovered asteroids often appear more threatening when they are initially observed. However, as more observations are incorporated, the threat associated with a specific object typically decreases. Should the asteroid pose any danger to Earth, NASA has a deflection system in place to combat the threat. The space agency tested the technology last year when it smashed its double asteroid redirection test, aka the DART spacecraft, into an asteroid named Dimorphos, millions of miles away, changing its trajectory. DART crashed into Dimorphos at 14,000 miles per hour, accelerating it by 32 minutes, shortening its orbit to 11 hours and 23 minutes. NASA says, "This mission shows that NASA is trying to be ready for whatever the universe throws at us. NASA has proven we are serious as a defender of the planet." While NASA is currently tracking 855 asteroids measuring at least 1 kilometer long, the agency is confident that these asteroids represent 99% of the big rocks in space that could cause planet-wide damage. However, detecting and tracking these objects is just the first step in protecting the planet from potential impact. NASA must find these asteroids years before they come close to Earth to have time to get a deflector spacecraft out to an intercept point and divert them in time. However, depending on the type of asteroid threatening Earth, an impactor spacecraft like DART may not be the best solution. Some asteroids are essentially a single piece of solid rock, while others are loose agglomerations of debris held tenuously together by their collective gravity. A DART-like probe may only make a bad problem worse by breaking up a rubble pile asteroid into smaller pieces. As DART scientists have pointed out, breaking an asteroid is not really the best way to defend yourself from it, because then instead of having one large object heading for you, you have a lot of little objects heading for you. It's not better. Deflecting a rubble pile asteroid would require a different kind of deflection system that is not currently in NASA's development pipeline. Overall, while the threat of asteroid impacts may seem daunting, NASA's ongoing efforts to track, monitor, and deflect potentially hazardous asteroids show that the agency is committed to defending the planet from these cosmic threats.